Hello and welcome to this video. In this video we will continue the methods of string type, and this is the fifth video if I recall on the string type. So let's get started. So the first function is replace n. It takes a string, it takes two strings and a counter. So the string on which it is invoked, example, it is invoked on s, which is foo123 foo. So we are looking for foo, placing foo by new twice. Okay, 2 is the counter. So it will replace first two foos with new, and then we will be left with 1, 2, 3 foo. Similarly, you can take s and replace o by a 3 times. So it will become FAA, FAO, 1, 2, 3 foo. And you can replace numeric characters also. So with new, so it will become foo foo new 23 foo. Let's see this in action. Argo run succeeds. The next function is rfind. If you see the description rfind, it returns the byte index of the first character of the last match of the pattern in the string slice. So if you are looking for L, then it will not return the first L, but it will return the second L. So it will return an option enum. So it would be sum 13, that is 13th position. Byte index of second L is 13, and byte index of this acute E will be 14, and byte index of part will be 24, because it will not match the first part but the second part here. So let's see this in action. Works. Now what you can do is you can supply it white space or closure. The white space will match the second one, second white space, and lowercase will match I think it should match the D. Yeah, it will match the D. Yep, carries lowercase, it will match D. So let's see this in action. Next function is R match indices. It is the reverse of match indices we have discussed yesterday. So R match indices will match the string, which is the argument, give the index of those. So the first ABC which it matches is this guy, ABC. So if you look at its position, then it is 6, 3, 6, 9, 12. So it is at position 12, this is at 6, and this is at 0. So it will return the vector containing this. Similarly, if you see this string, it will return the two matches, this ABC first and this ABC second. So the index would be 4 and then 1. Now if it matches ABA, then it will match this, and then there is no further match. It will return only one match. Now we look at R matches, which is reverse of matches. So it will start matching from the reverse, and you can see that when we match ABC with this string, it matches 3 times and gives us ABC. And if we match numeric, then it will match 3, 2, 1. Okay. Next function is split. There are lots of examples of split. Okay, we go through them one by one. So if you split by space, it will return the the entire string split by step. So in a typical sentence, all the words will be separated. If you split an empty string by anything, it will return empty string. And similarly, if we are splitting by one character, it will split by, it will give us empty string for continuous separator. So here X has come twice. So in between there will be an empty string. Now you can use something like double colon also, which will give here the string. And then we have numeric. So numeric means 1 and 2 will match. So it will give us 3 strings A, B, C, D, E, F, G, H, I. We can split by uppercase. We can give a vector slice. Okay, it's a vector, so it's slice we can take. And similarly, if you can use multiple characters in this, minus, space, colon, at the rate, all were used. So it gave 2020 11 03 23 59. You can use a closer. So here in the closer we supply at P as either 1 or as X. So we get A, B, C, D, E, F, G, H, I. We remove the separator is 1 and capital X here, this guy and this guy. So if you have multiple conjugative separators, then you will get multiple empty strings. Similarly, if the separator is at beginning and end, you will get empty string at beginning and end. If you use empty string as separator, then at the beginning and at the end you will get empty string. If you split by space, for example, which contains multiple spaces, then you will get empty string for all those. So that's how split works. So similar to split, there is R split, but the order of resulting strings is reversed. Now there is something called split once, and its analogous is R split once. So it will string the string only once, and if the separator is not there, it will return none. If the separator is there, it will split once, and if it is at the end, then it will also return an empty string. So here, for example, next example is CFG is equal to foo, separator is equal to, we get two strings triple CFG and foo. If there is CFG is equal to foo is equal to bar, we will get CFG and foo is equal to bar. I split once does the same thing, but the order will be reversed. So here CFG foo is split. Okay, so it will give you CFG foo. All right, and if it is CFG is equal to foo is equal to bar, then it will give you CFG is equal to foo is equal to bar. So that means splitting is happening from the right side. So that's why it is called R split. So the assertions succeed. Now we look at split terminator. So what it does is, if this separator is also the last character, then it won't return an empty string like split, because split would give you an empty string. In this case here, to be there'll be an empty string if you use split, but split terminator will not give you the empty string. But if there are multiple separators, you will get empty strings. Okay, at the end, that is, if there are two, then you will get one empty string. And here we can use multiple characters as well, like split. So that will happen. Now R split terminator behaves similarly, but in the reverse way. Next is split white space. It returns an iterator. So you can call next function on the iterator and get the words, which will return an option enum. And at the end, it will return none. And then split white space will also split by Unicode white space. So Unicode white space is also removed. So again, we have Mary had a little lamb, then followed by none. Now we will look at split n. So it takes n and it takes a pattern also. So what it will do is it will split the string, and if you look at its description, then what it returns is it will return at most n items. It won't return more than n items. So even though pattern is space, we have asked for 3. So it will split twice, marry, add, and then a little lamb altogether. If pattern is x and n is 3, then it will return lion, empty string, and tiger x leopard. If it is abxdef and n is equal to 1 and pattern is x, then no split will be done. Okay, it can return at most one string in this case. If it's an empty string and if you want one split and pattern is x, then it will return empty. And similarly, this closer example is also there. So we run this. Next one is split at. So it takes an index. So it will take an index which is called mid. Okay, and it also should be, it must be, not all should, but must. It must also be boundary of a UTF-8 code point. So you have to be careful about this function, because if you don't give a valid code point, then it will panic. Or if you go out of bounds for this, out of bounds means you give a position which is not present in the string, then it will cause a panic. So we have this string and we split at position 3. So we get per, and space is contained in the next one, Martin LOF. So this is split at. These functions are quite useful when you are writing code and performing logic in your program. They come in very handy. That's why we are studying them. Similarly, we have split at mute. So the functionality is same, just that the return values are mutable PRs in this case. So the small per is made capital PER by using make ASCII uppercase. Now we look at split inclusive. So it will take a separator, and in the return values, the separator will also be included. There is nothing new, nothing surprising in this case. Now we have two functions, strip prefix and strip suffix. So it will take a string and it will split, it will remove that string if it is found at the beginning, and return the remaining part of the string. But if the prefix is not found, it returns none. And it will do it only once. It will remove the prefix only once. Similarly, suffix does the same thing, but from the end. Now we look at lowercase function. So for example, here hello is capital hello is converted to small case hello. Capital sigma is converted to small sigma. But in the language, if sigma is at the end, then this is this, I don't know what character is this. So this will be the behavior when you are converting a string to lowercase Greek string. These are Greek characters. So if sigma comes at the end, it will be this character. Similar to lowercase, we have uppercase. It will convert a string to uppercase. And we have trim function, which will remove all the white spaces from the beginning and end. White spaces are like new line, space, tab, those are white spaces. So trim function will remove these white spaces from beginning and end. And then there are two more functions which are similar. One is trim start. So that will trim the string from the start, from the beginning. It will remove the white space, but it will not touch the white space at the end. Similarly, there is trim underscore end, which will remove white spaces from the end of string but not from the beginning. So we see this. So we see that we have covered almost all the functions of string. There are some traits which I have not covered, but as we proceed further, we will encounter them, and those use cases will be covered during examples. So now that we have covered all the string methods, in the next video, I will introduce option and result enum. With this, I will end this video here. I hope that you have found this video useful and informative. So please subscribe to the channel, like the video, share it to your heart's content, and make use of the comment box to speak your mind. And I'll see you in the next video. Thanks a lot for watching programming.